Hi, this is Scott Amyx, and I'm joined by Karsten Temme, co-founder and CEO of Pivot Bio. Welcome, Karsten.
Thanks for having me.
All right. So now, when you were working on your Ph.D. in bioengineering at UC Berkeley, you were fascinated by the power of microbes in soil. Can you tell us about that?
Well, microbes are responsible for being able to produce a significant number of the nutrients that it takes to grow plants. And one of the things that biology is uniquely capable of doing is taking nitrogen gas from the air around us and turning it into ammonia. And that's a form that plants can use to build protein and DNA and all the other things that it requires to grow. So that process of fixing atmospheric nitrogen into ammonia is one of the most complex types of things that happens on this planet. And it's really fundamental for making sure that we have life on Earth. That's what I studied during my PhD.
So how did that research eventually turn into your current startup? And I think you also got one of your colleagues involved as well.
That's right. Well, flashback almost 125 years, and the world had a huge challenge. The Industrial Revolution had meant we could support a bigger population globally, and we were faced with this big challenge of how do we feed everybody? And we didn't have enough fuel for our agricultural system at that time. And all of the scientists of the world said, if we don't figure out a better way to supply nitrogen in a form plants can use, we're not going to be able to feed the world's population. So for the last 125 years, scientists globally have tried to unravel how microbes can take this nitrogen from the air and turn it into ammonia. And during my PhD, we finally got to the point we said, we can build the blueprint. We've reverse engineered how biology does this well enough to build the blueprint for the first time. And my co-founder was in lab working on similar projects with me, trying to think about how microbes are a lot like computers. They're wired to be able to sense the world around them and do these phenomenally fabulous and important things. And we left our PhD with a blueprint on how you take nitrogen from the air around us and power all of agriculture.
Wow, this is so fascinating. I can't wait to get into the science of this. I'm just really excited to dig in. But let's first talk about today's current synthetic or chemical fertilizers. What is it currently made out of, and why is that necessarily bad for the environment and farming and, of course, the food sources?
Sure. Well, the solution 125 years ago was via chemistry. Chemistry was this new field of science that was invented in the 1800s, specifically things like organic chemistry. And a few German scientists, Haber and Bosch, invented a chemical process to take that nitrogen gas in the air and turn it into ammonia. And they built huge chemical factories to do that. So today, our agricultural system is really powered by fertilizer, this process that the Germans invented. And half of the productivity of our food system on this planet would go away if we stopped using fertilizer overnight. So we're really dependent on being able to use fertilizer as a fuel to produce our food. And the challenge is it has a number of side effects. And those really threaten the sustainability of how farmers can have a profitable farm and the sustainability of the agricultural system and its impacts on the environment and climate around us. So we can talk more about those if you'd like to get into some of the details on the side effects of fertilizer.
Well, let's focus on actually Pivot Bio specifically. So
Sure.
Let's get into a little bit more depth. The next layer of how are the microbes able to actually deliver nutrients, that blueprint that you referenced before. And I think you go even further to claim that it also protects against pests, as well as just improving crop quality. So walk us through that blueprint.
Well, when a plant grows, something like 30 or 40% of all of the carbon dioxide that it fixes during photosynthesis is turned into sugars. And these are complex sugars that the plant exudes out of its roots to feed microbes in the soil. And so the plant has a microbiome, just like you or I have a microbiome inside of our gut. And what the plant is doing is feeding all of the microbes in the soil, the trillions of microbes in the soil, a select menu of sugars. And that's like a dinner party where there are only a few invitations sent out. So trillions of microbes in the soil and only a few hundred types of microbes can form this mutualistic relationship, a symbiosis with the plant, where they can do something beneficial for the plant in exchange for a food source. One of the most important things that those microbes can do is produce nitrogen for the plant. So what we do at Pivot is we rediscover those microbes that are capable of making this nitrogen for a crop, and we turn that into a product. And the big challenge there is that those microbes have gone into hibernation over the last 125 years because of the synthetic fertilizer we use. Every time we dump fertilizer on a field, it signals to those microbes to go further into hibernation. And so we have to rediscover them and wake them back up and then design a product that's easy for a farmer to use.
So let's just kind of try to understand a little bit more. So in this case, instead of feeding them the chemicals that the farmers are used to, you're effectively feeding them a specific type of sugar compound that is then going to wake these microbes. So kind of, if you go to the next layer, that would be helpful.
Yeah. Think of what we're doing is we're building a probiotic that you give back to the crop.
Got it.
And what it does is it reawakens nature's own design for producing nitrogen. So we no longer need to add that fertilizer to a field.
And that probiotic, it's fairly resilient, right? So it can come in kind of a dry form or liquid form. And how does it actually stay within the soil so that doesn't get washed away?
Well, it's dependent on the plant for its food. And so when the crop gets harvested, the microbe dies off. Now, what happens is when the seed begins to germinate and the first roots form, the microbe, it latches onto those roots and it fits them like a glove. And so then it's just making nitrogen for that plant every day. It's taking the gas from the air and turning it into ammonia, spoon feeding the crop all throughout the growing season.
That's amazing. Wow. So tell me about, why is Pivot Bio, the science and what you guys are doing, so critical in terms of timing of now?
Well, it's the time when the side effects of using fertilizer are really starting to amplify into some pretty massive global problems. One of those is that the use of fertilizer is a significant contributor to greenhouse gas emissions. Anything from producing fertilizer that releases a lot of CO2, applying fertilizer and driving a tractor across the field, and even some of the fertilizer itself turns into NOx emissions. And NOx is 300 times more potent than CO2 as far as a greenhouse gas potential. In addition, about half of fertilizer is washed away by the rain and turns into pollution of our waterways. So if you ever hear of big algal blooms that make the water so toxic that nothing can live, that's really linked ultimately back to fertilizer use. So down in the Gulf of Mexico, there's a big algal bloom at the mouth of the Mississippi that's almost the size of New Jersey. So toxic that nothing can live there, and it's all because the fertilizer from the Midwest is getting washed down the Mississippi and collecting in the Gulf of Mexico.
So there was a 60 Minutes coverage where they were actually interviewing farmers about the use of certain type of synthetic pesticides. And a lot of the reaction from the farmers was that it's something that they absolutely needed, and whether it caused cancer or it had any type of side effects, that for their farming, their agriculture to be sustainable in the sense of economically sustainable, that they needed these synthetic and chemical fertilizers and pesticides. So my question is, how are the farmers reacting to Pivot Bio? And then from a cost structure, how does that compare to what they're used to paying?
Yeah, so let's set aside pesticides. That's an area we don't play in, but fertilizer, it's really the fuel that makes the whole of the agricultural system possible. I mentioned earlier about half of our productivity would go away if we stopped using fertilizer. So there's some really massive ripple effects associated with the power of how fertilizer makes everything possible. And the challenge is just we have these significant side effects that we have to deal with. The beauty of our product is it's the first time we really can have an alternative way of producing nitrogen without those side effects. And so what we see when we talk to growers is a phenomenal amount of excitement, because this is the thing they've all been waiting for as a community, essentially for 125 years. It's really nature's solution for producing nitrogen, and we've just kind of deviated course for a little more than a century through the use of synthetic chemical fertilizer.
And how do you show them the efficacy in terms of the fact that it can, be as productive as chemically based, but it's purely natural without all the externalities?
It's a unique moment in time, because there's a real excitement and receptiveness among the farming community to build new relationships. And so companies like ours, we can really make a direct connection with growers and help them to test our product on their own farm. And then you have years like this where we had, if you remember in the spring, so much rain that just it really challenged farmers being able to even get into the field to plant a crop. And then throughout the summer, we had an extreme amount of rains, heavy storms that would roll through on a weekly basis. And all of that precipitation, it really does a huge amount of damage to how much fertilizer is left behind for a crop to use. And so if a farmer is working with us and testing out our product on their farm, this is a great year to be able to see just how much more our microbe sticks around, it's adherent to the roots, how that nitrogen is a dependable source of nutrients for the plant on a daily basis. And contrast that with the challenges of trying to manage fertilizer that's getting washed away on a daily basis.
Yeah, it's really fascinating. I mean, it's a fundamentally game changer because, like I said, typical fertilizers will simply wash away with the moisture. But here, because of that, that biological binding aspect, there's no amount of water or rain or even flooding that's going to actually change that relationship, the symbiotic relationship. So that is really interesting. And then what's the kind of results that they're seeing? Have you had enough of a study and a kind of a full cycle to see if, in fact, this is producing the kind of yield that they're used to?
We have. We actually have been testing our product with growers for the last 6 years. So it's something that the product that's on the market today that's commercial is really the result of many years of scientific testing, many years of product development, and a lot of feedback from all of our early adopters. And so the three things that we're really ultimately trying to do is make sure that every farmer is more profitable, and then that the whole system can scale for the future needs of the planet without creating the kind of side effects that we have today. So that first one, the profitability, what we're trying to do is ensure that the crop and the harvest that's produced every year is a lot more consistent and dependable, and ultimately a lot more profitable for every grower. And so those are the kind of metrics we pull in off of all the testing we do. And what we see is a phenomenal set of results that by and large, almost all of our customers are coming out ahead when they look at their bottom line at the end of the year.
Yeah, absolutely. And that's what you need is the economic indicators and the success factors.
Mm-hmm.
Speaking of product development, can you share with us a little bit about some of the current projects as well as a future product roadmap?
Sure, happy to. And about half of the world's fertilizer today is used on just 3 crops. So corn, wheat, and rice, we use more than half the world's fertilizer just for those 3. So that's where we spend a lot of our focus in terms of our development pipeline. And we've got products for wheat and rice that are pretty close to being launched in the marketplace. Then we also work with developing products for a number of the other types of cereals that are pretty important around the world, whether it's sorghum or barley or millet, things that are either staples or pretty big drivers of a farmer's income. And the focus for us then is how can we make the biggest dent in the fertilizer market as fast as possible, and how can we find partners out there who can help us apply the technology to even more kinds of crops, things like fruits or vegetables, or permanent crops like different types of orchards or nut trees.
So on the latter part, I just want to make sure when you say partners, are you saying it's essentially kind of a licensing model that they can then take and apply to things that's not core to your portfolio?
Great question. And really think about it two ways. One could be that we're looking for partners to help us take the technology and together collaborate on expanding it for developing new products. And then the second type of partnership is to be able to help bring those products into the marketplace. So I think we're really focused on trying to make sure we have strong relationships with the growers that use our products. And to imagine that we'd be able to build out the kind of commercial team that could connect with farmers everywhere is just a challenge that's beyond the scope of a company our size. So we're really going to need some help from partners that are connected with growers all around the world or in different types of crops.
So let me know if this is appropriate to talk about, but one of your early investor was Monsanto, which is now part of Bayer.
Mhm.
And I think, at least from my point of view, and please correct me if I'm wrong, I think it is a beautiful strategy because you will actually help them not only to increase their product portfolio, but ultimately, as the world demands safer, more organic and sustainable solutions, that they can start to shift away from the chemical and synthetic to something more natural. And of course, they have the distribution, the coverage, and the relationships. Are you able to talk
Yeah,
about
happy
that?
to talk about kind of our strategy. And I think the thing that is really important to remember is we've got a pretty well developed and established agricultural system. It's the result of innovation across decades and centuries. And a product like ours, an innovation like ours, is going to be just one more tool in the entire toolbox available to a farmer. And so the best thing we can do is bring change and improvement from within the system. And so one of the things about the relationship we have with Monsanto Growth Ventures is it opened a lot of doors for us. It helped us with some credibility among growers in the US. It really gave us some insights into how the industry works today. And one of our requirements is that it came with no strings attached on how we commercialize our products. It's something where I think at the time Monsanto had some great foresight to say there's a lot of new opportunities for innovation from outside of the big multinationals. And if they could create a standalone entity to do some investing like a venture capital company, they might help spur on that innovation, but also help open the doors for the parent organization, Monsanto and now Bayer, to be able to learn about what might be the next type of innovations that help improve the industry. So for us, it's really helped build some relationships, pave some paths on how we might help the industry move one step closer to a more sustainable future, and do it in a way that doesn't constrict us or define how we bring this innovation to growers everywhere.
All right, I have two more questions and we'll wrap it up here. Is why are some of the VCs so excited about what you guys are doing? So Breakthrough Energy Ventures, backed by Bill Gates and many other luminaries, as well as some of the other major players as well. Why are they excited to work with you guys?
You know, it's the kind of problem that's a massive challenge. It's a huge market. The global fertilizer market is over $200 billion, and it's something that can be really disruptive. It really is not just a technology that can be a replacement, but it can offer new types of features you can't otherwise get from the existing incumbent fertilizer product. You know, our microbes can spoon feed that plant every single day, and that means less work for a farmer, more peace of mind. It's easier to use, and without all of the sustainability side effects. So, in some ways, it's about being able to go after one of the biggest challenges we face on this planet, and do it in a way with an innovation that means we're in a place we never thought possible. I think that both fits well with the kind of aspirations a lot of investors might want to have in terms of impact, but also it just makes really strong economic sense from a venture model and a growth model.
Yeah. So my last question is, what was your greatest product innovation failure, and the lessons learned?
It's a good question. I think there are always a lot of lessons learned because in some ways the best experiments are ones where when they fail, it helps give us a path forward. It's not just saying that the idea didn't work, but now it spurs on a new way of thinking about what comes next. So maybe an example to highlight is really the story of how the company got started. My co-founder Alvin and I left graduate school with this blueprint of how microbes fix nitrogen for plants. And our first funding came from the Bill and Melinda Gates Foundation. And we had some funding also from DARPA. The question we were asking is this blueprint enough to where we could make a transgenic corn plant that could fix its own nitrogen without even needing any microbes? Could you take all of that genetic program and turn the DNA into something that was embedded into a plant? Could you make a transgenic plant, a GMO plant, that never needed any fertilizer? I think what we realized is that was just the wrong way of thinking about it. The better type of product that's easier for farmers to use, it's going to be more palatable to consumers, and really where consumer demand is driving us is something that looks like a probiotic that looks just like nature's own solution. And it's going to be faster to innovate, faster to make a dent in the world, simply because it's such a challenge to build a transgenic crop.
Yeah, I mean, those are completely different paths, and I'm so glad that you guys decided on the current path that you guys are on with Pivot Bio. So today I've been joined by Karsten Temme, co-founder and CEO of Pivot Bio. Karsten, thank you so much for joining today.
Well, thank you so much.